Alright, so today we're going to prove the following equality, that the square of a plus b is equal to a squared plus 2ab plus b squared. And the way we're going to do it is that we're going to use a geometric proof and use a square of side length L. And we can pick a random point on this edge such that the length on this side is a and on that side is b, and we have that L is equal to a plus b on this side, and we pick another point on this edge such that it is the same exact length. A is here and b is there, and we can draw two straight lines on the square like so. Now on the side, I'd like to remind you that the area of a square is its length times its width, and in our case the length and width are the same, so it's going to be L times L, so the area of a square will be L squared. In our case the area will be L squared, but L is equal to a plus b, so it will be a plus b squared. That's our first result for the area. There's another way to look at the area, is the sum of the different areas within this square. So if you look at this square, it has side length a, so it has an area of a squared. The one in red here, each side is of length b, so it'll have an area b squared. This rectangle has a length of b and a width of a, so it's going to have an area of b times a, while this one has a length of a and a width of b, so it'll have an area of a times b. So we can rewrite the area of the square as the sum of these different areas. So starting with a squared for the blue square, b squared for the red square, ab for the first green rectangle, and ba for this second green rectangle. Remember that ba equals to ab, since they're both just numbers, the order of multiplication doesn't matter, and we can combine then these two expressions to get a is equal to a squared plus b squared plus 2ab, and we can move this 2ab here and rewrite the equation as a squared plus 2ab plus b squared. That's our second equation. Box it up. And since both equation 1 and equation 2 relate to the area of the square, and since it's a constant, then equation 1 must equal equation 2. Hence we have a plus b squared is equal to a squared plus 2ab plus b squared.